Have you ever wondered how an app knows your password is right or how a game decides you've leveled up? Well, it all boils down to one thing: making decisions. And in this explainer, we're going to give your Java code a brain, teaching it exactly how to make choices using what we call conditional statements.
So here's what we're going to cover. First, we'll get into why this is so important, why our code needs to choose in the first place. Then we'll jump into the absolute fundamentals with if and else. From there, we'll see how to handle lots of different options, check out a neat alternative called the switch statement, and then wrap things up with some pro tips for writing smarter, cleaner code. All right, let's get into it.
Okay, so let's start at square one. We need to understand how a program thinks, or maybe more accurately, how it doesn't think when you first write it. I want you to picture your code as a train on a single straight track. It starts at the very first line and just chugs along, one instruction after the next, until it reaches the end of the line. We call this sequential execution. You know, it's reliable, it's simple, but it's not very smart. It can't really react or adapt to anything that happens.
Right? What if you want your program to do one thing if a user is logged in, but something totally different if they're not? Or maybe in a game, you need it to do something special the moment a player's health hits 0. A straight line just isn't going to work. Your program needs to know how to handle a fork in the road.
And that is exactly where these things, control statements, come into play. Think of them as the signals and switches that allow our train to change tracks. Now, as you can see here, they come in a few different flavors, but today we're zeroing in on selection statements, specifically if and switch. These are the absolute bedrock of decision-making in Java. So let's start with the most important, most fundamental building block of them all, the if statement. This is pretty much your code's first and most powerful decision-making tool. This slide just lays out the logic perfectly. On the left, you've got the syntax, the word if, followed by some kind of test or condition in parentheses. If that condition turns out to be true, the code inside the curly braces gets to run. The flowchart on the right shows you exactly what's happening. The program gets to a decision point. Is the condition true? Okay, follow this path. Is it false? Nope, just skip that whole block of code and keep on going. Let's make this real. Have a look at this example. This little program asks for a number, and then we get to our condition. If f condition num%5 equals 0. Now that percent sign, that's the modulo operator. All it does is give you the remainder of a division. So what this condition is really asking is, hey, if I divide this number by 5, is the remainder 0? In other words, is it perfectly divisible by 5? And here we see it live. On the left, someone typed in 12. So, is 12 divisible by 5? Nope. The condition is false, so that code inside the if block gets completely ignored. The program just prints that final end of program line. But look at the right. The user enters 20. Is 20 divisible by 5? Yes, it is. The condition is true, so the program dives into that if block, runs those 2 lines of code, and then continues on. See the difference? Now, a simple if is great, but it really only cares about the true case. What if you want to do something very specific when the condition is false? Well, for that, we bring in its partner, else. Now look at the flowchart. There's a dedicated path for both true and false. No matter what, our code is going to follow one of those 2 branches. This makes our logic way more complete. And this is the classic example you'll see everywhere. The condition num%2 equals 0 is just a clever way to check if a number is even. If it's true, the code in the if block runs and tells us the number is even. But if it's false, the program doesn't just give up. It jumps straight to the else block and prints that the number is odd. The key thing to get here is that one and only one of these blocks is always going to run. And here's the proof in the pudding. We run the code, we type in 16, the program checks. Does 16 divided by 2 have a remainder of 0? Yep, it sure does. So the condition is true, the true block runs, printing that it's an even number, and that whole else block is just completely ignored. It's such a simple, powerful, and clean way to handle 2 different possibilities. All right, so we've got one condition with 2 outcomes totally nailed down. But what happens when you have 3 possibilities, or 4, or even more? Well, that's when we need to start building a ladder. This structure is just fantastic for handling a whole bunch of options that can't happen at the same time. Let's trace the logic on that flowchart. First, the code checks, is the score 90 or higher? If not, okay, let's move down to the next rung on the ladder. Is it 80 or higher?
If not, it just keeps going down the ladder until it either finds a condition that's true or it gives up and hits the final else at the very bottom. It's a much, much cleaner way to do this than trying to stuff a bunch of if statements inside of each other.
So when you have a whole bunch of options that are all based on the value of just one single variable, that if-else-if ladder can start to get a little long and repetitive. So let's look at a more specialized tool for that exact situation, the switch statement. The whole point of the switch statement is clarity. You give it one variable to look at, in this case its value, and it literally jumps directly to the matching case. It's kind of like an old-school switchboard operator connecting a call. If the value is 8, boom, it jumps right to case 8. Now that break keyword you see is super important. It tells the code, okay, we're done here, get out of the switch block. And if none of the cases match, it just lands on the default option at the very end.
So this brings up the big question. Which one is better, switch or if-else-if? Well, one argument for switch is all about performance. See, behind the scenes, when a switch statement has a lot of cases, the Java compiler can get really clever and turn it into something called a lookup table. This basically means it can find the right case in one single jump, instead of having to check each condition one by one like that if-else-if ladder does. But let's have a reality check here. For most of the apps you're going to build, that tiny performance difference is, well, you'll never notice it. What's way, way more important is readability. Your goal should always be to write code that's easy for another person, or for you 6 months from now, to read and understand. So honestly, the best choice is usually just whichever one feels cleaner and makes more sense for the problem you're trying to solve.
Okay, now that we've got the main tools in our belt, let's look at a couple of ways to add a little bit of pro-level polish and make our conditional logic more concise and, well, just more elegant.
Check this out. On the left, you have a perfectly good if-else statement. It works, it's clear, but it takes up 4 lines of code. Now look at the right. That is the exact same logic, but we've squished it down into a single line using something called the ternary operator. It's clean, it's compact, and you will see this shorthand used all over the place in professional Java code.
Let's just quickly break it down. The structure is super simple. First, you have your condition, then a question mark. After that comes the value you want to use if the condition is true, then a colon, and finally the value you want to use if it's false. It's basically a mini if-else statement that's perfect for when you just need to assign one of 2 values to a variable.
And just to give you a little peek at what comes next, as you start writing bigger and more complex programs, you might find that huge if-else or switch blocks can get really messy and hard to manage. A more advanced solution to this problem is a powerful idea called polymorphism. The idea is, instead of your code making all the decisions, you let the objects themselves decide how to behave. It's a huge concept in object-oriented programming, and it's something you'll definitely get into as you continue your journey with Java.
And there we have it. We've gone from code that could only walk in a straight line to code that can actually think, evaluate conditions, and choose its own path. We've covered the basic if-else, the multi-option switch, and even glanced at some more advanced techniques. You now have the fundamental tools to make your programs truly intelligent and responsive. So the only question left is, what decisions will your code make?